meeting is being recorded.
All right. Welcome everybody to this session of SIG scheduling. Today is December 15th. And as you may know, this meeting is being recorded. So for this, we actually have a kind of a packed agenda. We wanted to start today mentioning a few of the things we are already planning to do for the 127 release. Let me try to share my screen. So
you get muted when you share.
That's still the case. Huh? Okay. Can you share for me, Abdullah?
Yeah, can you give me back co-host? I think I gave. Yeah, can you make me a co-host?
1 second. Okay, so meantime, as I was trying to say that sorry about my cat. We were with the help of SIG scalability, we were running some performance tests, and we discovered a few low-hanging fruits that we can do on the scheduler to elevate the throughput. Yes, you might know for several releases we've been working on performance, and we are really getting down to the very low level details, but there's still room for improvement. So here we open a list of issues where these issues will actually improve the performance of the scheduler. There are a few. This one is about some calculations, if I remember correctly. Second one, right. That's also, yes, calculations. Some of them are closed even already. Some of them require API changes. For example, the third one might require adding some configuration to the kubescheduler config, which is the component config for the scheduler, and yeah, more optimizations here and there. Maybe more interesting is the last topic. In the scheduler, we try to not retry pods when we have determined that they are not schedulable until there is an event in the cluster that might make them schedulable. So for example, if a new node is created, we retry. We put the pods back into the active queue, but we have even extra checks. For example, if the pod has a node affinity, we immediately check just the affinity for that new node, sorry, and then if it doesn't satisfy, we skip. So we in general we ended up doing a lot of quick calculations to reduce the amount of retries for pods. But there is still an unconditional retry of pods, which we call flushing. So after a certain period, the pods are put back into the active queue, regardless of why they were unschedulable. And we've been experimenting with increasing this timeout or this flushing period, but giving the ability to revert just in case we still have some bugs. So this issue is mostly about increasing the flush period even further. We are currently at 5 minutes by default. We want to make it 15. But we still want to keep the option of reverting it back. So, and we want to do that through the kubescheduler config API. So this is what the issue is about. If you have any concerns, I think we've been doing this carefully through other releases, and there hasn't been issues lately. So that's why we are proposing to increase the period even further. But please communicate any concerns if you have any. And another area where we want to make progress on is on improving logs and metrics. So currently, when we have when a filter runs, we don't know if a filter actually made sense for a particular pod. For example, if we have the node affinity filter and the pod didn't define any node affinity, we want to be able to tell in metrics that this filter didn't do any meaningful decision on this pod. That way, for any new feature that we add, we can more clearly tell whether there are pods that are using the feature. So this is what this issue is about. The first step is actually determining some form of status that clearly says that the plugin didn't do anything meaningful. So that's the current work that Kensei is doing. But then we have to migrate. We have to do a pass through all the plugins to make sure we are using this new distinction. And with that, once that is finished, we would also like to include that into the logs, so it's more easy to debug. And there is some we could generalize also for score plugins, but we haven't really thought of all the implications. But once we finish this, and if there is still time in the release, we can definitely look into improving metrics and logs for scoring. So yes, that's kind of on the small side of things that we want to achieve during this release, things that don't require caps. Abdullah, over to you to talk about the bigger features, caps.
Can you hear me?
Yes.
Oh, and you can see my screen?
Yes.
Like, is it frozen or?
No, it's working correctly. It's moving.
Oh, okay. Okay, so yeah, we've got like 1, 2, 3, 4, 5 caps that we would like to graduate. I don't think we. I think we have only one that is proposed as new. So which is the first one. So if you recall, we introduced the idea of match label keys to pod topology spread to solve the problem of, when you update a replica set, it goes through like a rolling update. You wanted a way to basically apply the constraints on the new replica set, not on the old one, right? Like, because while you're doing it, the old one, we know that at some point the pods will be downscaled and removed. And so those older pods from the older replica set should not be taken into account when doing the calculations of skew and whatnot. So there is a proposal to introduce the same idea to pod affinity and pod anti-affinity. I think it's reasonable, making the APIs symmetric. Although I expect that pod topology spread is the one that will be used more often for pod anti-affinity instead of pod anti-affinity in general. I'm not sure how much usage we have for pod affinity. But I mean, it's nice to have. I wouldn't say like we should block it. So that's the first one. The others are like, again, this is the pod topology spread one. It's the same as I discussed for pod topology spread. So we want to graduate this to to GA to stable. It's 125 now. I think this is a really nice feature. It actually makes it easier in general to use pod topology spread. Instead of specifying both label and key and value, you can only you only need to specify the label key, and the value will be automatically detected by the scheduler. The third one is the mutable scheduling directives. So this is in beta as well, and the hope was to graduate to GA stable 25, but we're going to do it in this release. So this is basically allowing to change the pod affinity on the job pod template. This is basically related to the whole strategy of adding new hooks into core Kubernetes to allow higher level job schedulers to do their work. I don't think any of those are controversial. And the last one is the PDB enhancement related to the schedule having more guarantees on like having the scheduler respect pod disruption budget, I guess, on preemption. I don't recall the exact details of this one. Like, what is it that we're trying to change?
I can mention a little bit. So the background is that PDB was the sort of the first-class citizen in terms of preemption since day one, but it's a best efforts manner. That means only like 2 paths both have PDB protected, and then on each node, then they are tied. Then in this case, we will preempt the PDB protected path anyways. But in other case, like, I mean, by best efforts means, okay, if there is a path not have PDB protected, and then another path protected by PDB, then we will definitely choose the path without the PDB protected. So that is why I call it best efforts manner. But some users says, okay, PDB represent the disruption semantics in all dimensions, not only in preemption in scheduler, but also in like the eviction API, etc. others. So it's reasonable for us to at least give an option to the user says, okay, PDB is PDB. Don't preempt the path protected by PDB. So if we come up with the option to honor the PDB's semantics, to honor the disruption, I think Abdullah, you gave a comment on some of the option. Like, yeah, option 4 should be the most desirable to give. Yeah, you remember that? Okay.
Right. That sounds good. Yeah. I thought this is a graduation, so it's I thought we made some progress on this one. So this is basically a net new feature as well, right? Like
yeah.
Okay, sounds good. All right, so that's the list of.
I have a clarification, Abdullah.
Yeah.
Yes, you linked this one, which needs to graduate to GA, which is about min domains.
Yeah.
Right. But we also have another cap for topology spreading, which is the one about match label keys. I just added it to the notes. That one is still in alpha, so we need to make it beta in 127. The next point in the doc, the next link. That one.
So this one, the min?
No, the topology spreading after rolling upgrades.
Yeah, this one is latest more. Oh, okay, right. So we're graduating from alpha to beta. The other one is from beta to GA.
Correct. Yes.
Sounds good. Okay. Yeah. So this is an overview of like the features that we will probably focus on in 127 for the scheduler. Please, if you have any like other things you have in mind, please add them here because we need to like go through the opt-in process, I think, again, like last time. So you need like a lead to tag the issue so that it gets tracked. So yeah, back to you, Aldo.
Any questions?
And I think Abdullah missing the past schedule readiness. So we're trying to get it the beta, although it's pretty new in 126 as alpha. Yeah.
Okay. Well, any questions, or we can go to the next topic? Okay, so Sergey?
Hi, thank you for having me. I came here from SIG Node for the sidecar, for early announcement of sidecar cap that we plan to run in 127. If you don't know about sidecars are containers that run inside the pod and doing some infrastructure ambient work. It may be a logging container, some metrics container, or it may be a service mesh proxy that runs inside the pod and overrides all the networking. So all the networking will go through this proxy instead of regular network. So the sidecars problem is that they will not run, they will affect pod lifecycle if you implement sidecars as regular containers. And that is a big problem. So we were trying to address this problem for a long time to enable this scenario for our customers. And in 127, I think we get to the point when we know what API will look like. So if you switch to this email, yeah, there is the proposal that is currently on the table, and everybody seems to be agreed that this is what the desired state will be if we design from a scratch. We want to extend init containers with new type of containers with restart policy always. So those init containers will run in the same order as regular init containers would typically run. The only difference is that we will wait for readiness of these containers, and then we will move on to next one, leaving this one alone. So it will live through the initialization stage, through the regular containers lifecycle, and they will not block the termination of a pod. So if all other containers in a job, for instance, completed, then these containers will be terminated by kubelet. So this is overview of a change that we propose. And now it has a lot of issues for customers and issues for implementation because, I mean, one obvious one is backward compatibility. Now, like before, people didn't expect that init containers will survive through the life cycle. Now, some of them will be. And from scheduling perspective, this change will mean that the resource calculation needs to change. So if you want to understand whether a pod will fit into specific node, the formula before was maximum for init containers and maximum sum of all other containers, and you take maximum of all of that. Now you need to be more elaborate because these sidecar containers, they will run during the initialization stage and will survive through container stage. So as a minimum, you need to sum them up to all the regular containers. But then in initialization stage, we can either go with simple approach to just take a maximum of all of them, or more complicated approach when we understand the order of startup and take maximum of like specific chunks of sublists. I can explain more. But the key point here is that calculation of resources will be changed without major change of pod structure. So like ideally, we want to extend init containers at least with this extra new containers. So now I want to open for knee-jerk questions and maybe some recommendations, some like suggestions. I can talk about some ideas we've been running around backward compatibility, how to work around this problem. But yeah, I want to hear questions first.
Can you
I'm
explain
trying. Yeah, go ahead.
the semantics? Like you have the example here, the ST proxy. I'm not sure I understood what the semantics for the always restart policy here. So you go through the containers and it containers one by one. The current semantic is that if one fails, you continue to restart, but you don't go down the list, right? Until that succeeds.
Correct.
And here, when you get to this one, the one with restart policy always, what happens? What is the difference?
For this one, we will wait for readiness of this container. So if container needs to go through startup stage and get into ready state, if they define the readiness probe, then we will wait for probe succeeded.
Okay.
And then we will move on to the next one. And restart policy always indicates that whenever it will crash, even if it will crash during the like after the initialization stage, we will keep restarting this container.
Okay. And so in this case, basically the difference is that this container will be allowed to continue to run after you finish. This is the new semantic as well, right? Which means you need to change the calculation to take into account that it's not just the maximum, you need to add it up to whatever like the pod spec, the normal containers have.
Exactly.
Okay, that makes
So,
sense.
so it looks like it's like a regular container that is always running out there with other containers specified in the spec.containers spec, right?
Yeah, it looks like regular container. We need it during initialization stage because some of the service meshes provide TLS network for everything, and including init containers themselves. But then there are some init containers that initialize sidecars. So in this example, we download a certificate from some vault, and then once we have a certificate, we can enable TLS networking for entire pod, and all containers after this Istio proxy, we will use Istio proxy for all the network communications, and nobody allowed to use regular network after that.
Okay, yeah, it's just in the sequence, it should be initialized before the regular containers. But other than that, resource consumption and the life cycle is basically the same as other. Yeah. Okay.
Well, there's
Yeah.
a difference, right? Because those containers are not expected to run to completion before the main ones. And so there is a significant difference in how we calculate resource requirements for the pod.
Yeah, that's an implication. Yeah.
Yeah.
Any
Because for other regular, I mean, all the init containers, it waits for its completion to go to the next. But for this kind of one, it waits for maybe the readiness gate for it to claim it's ready, then go to the next.
Right.
Yeah. All right.
any questions from the public? I have a request that when you go through these changes, we should probably have a single library, probably in component helpers or in the component helpers staging repo, because we have had issues before where there was a slight difference in the implementation between kubelet and scheduler or cluster autoscaler, and then or even I guess the resource quotas. So yeah, we really should have a single implementation that is shared among all of these systems.
Yeah. Cluster autoscaler too, right?
Yes, but I guess cluster autoscaler just uses the scalar code, so maybe it's not a problem. But
so if you will have it in sorted out in scheduler, the cluster autoscaler will be fine.
right, so it's more about kubelet, API server, and scheduler to have a shared implementation, so we don't have problems. So if there is some intermediate work needed to first, do the cleanup or the refactoring, let's do that first and then change the implementation.
It's a good
And
suggestion.
I suppose there will be some backwards compatible, like we support 2 kubelets behind, right? So does that mean that we only would be able to enable the feature within 2 releases?
Yeah, it probably will have this weird life cycle. Like any pod changes, pod spec changes, they're really hard to implement, and the life cycle of them is very long because of SKU policy.
Right, okay.
So one question I had is, once you have this library to share resource calculation, is there I know there are custom schedulers. I know there are like some plugins. How much this backward compatibility will hit us from perspective of third-party tooling? Is it something we need to, I mean, is it something big enough so there is no way we implement it and we need to go different route and rename something significantly so it will be like breaking change-ish? Like so people wouldn't just list init containers any longer. Or it's manageable, and with enough communication, we probably can get away with just adding things to this collection.
So when people implement custom schedulers, they are encouraged to use the existing plugins. And that, yeah, so once we fix the scheduler, the kube scheduler, they should be able to benefit from the existing plugin, the no resources fit plugin. But they might have extra plugins, I don't know, for quota calculations or things like that, which might break. But I don't think as Kubernetes project, we can offer guarantees in that regard. Wait, do you have any thoughts, any extra thoughts?
Yeah, I have the same opinion that the customer stuff. So basically, we define the API. The API is some sort of contract we all agree on. But if your implementation is lagging on that, you have no ways to prevent that, right? So we have no way to enforcing a custom scheduler to always be synced with the API. That is all just the implementation side to always adhere to the API.
And given that we would only be able to graduate, let's say, to beta in 2 releases, at least that gives some period where they can get up to date with implementation.
And
Okay.
also, I want to give ever correct someone's maybe mindset on thinking about customer scheduler. So basically, recently I look at some code of the third-party scheduler like Unicorn. So like in their document, official document, they claim they supported the latest 1.5 or 1.4. But that's not really the case, because I look at their, for example, Unicorn, their dependencies only upgrade to dependency the Kubernetes 122. That means if we introduce a new field in the 122 or 123, they even are not aware of the new field. So how come they are compatible to honor the new API? So, well, just get you some idea that when some third-party scheduler claims it supports 1.25 or something, you had to look into the real stuff, dependency, etc. Also the logic out there. So yeah, not every custom scheduler is following the real API to, if they are run their own, they're not re-implementing the API. So that's the thing.
Yes. So I guess in short, we cannot provide guarantees as a Kubernetes project. So
yeah, I mean, ideas for backward compatibility we had is completely deprecate init section and have a new section with the same properties as init sections today with new containers. but it doesn't make things much better because people wouldn't know about this new section, and they will just not. I mean, they would probably have the same problem with this new section as they have a problem with new flag on existing section. And another proposal was to have a fake containers in containers section that will duplicate the sidecar containers, and they will be ignored by kubelet when they actually scheduled. I don't know how much you want to invest into that workaround, but it sounds a little bit too much to worry about. But if you think that it's something we need to think about, I mean, I would really appreciate the feedback.
What's the best way to get involved here? Is there a cap already?
So
Or-
we rising cap early January we will have a cap out. It's kind of a big change, and we already had like 3 or 4 attempts to write this cap. So this time there's a big working group. So hopefully, and we already get API approval. I mean API like head nodes on APIs. So we will be. I feel we are in much better shape in this time around. So yeah, I will send a cap link once we have it to this group as well.
Thank you. Michelle, do you need how long do you need? 10 minutes? I have one more question, but I don't
Oh,
want to.
no, it's very quick.
Okay, so one more question. So this is about a startup. Are there any thoughts about tier down? For example, when you have a job, right? The main container finishes, but then the sidecars continue running, and that prevents
This is
the
exactly what we
job
have to
from
address.
terminating.
Yeah,
Sorry, go on.
sidecars will be terminated once job completed. So this will be implemented. One big problem with trying to wrap our head around is what do we do during graceful termination of regular pods or regular containers? Because if it's Istio providing networking, then networking will be needed during termination. So we need to be really careful in like ordering and restarting if this proxy crashed, we need to restart it, even though we are in termination stage. So it's a big change for us. But yeah, jobs probably will be addressed for sure.
It seems reasonable to basically think about it as like the first to start and the last to terminate, right?
Yeah, and
And
also, yeah, and also they will be sorry. Also, they will not block the termination of pod.
Okay, so once the main container or all the main containers finish, you start terminating, sending SIG terms to each of the unique containers in the reverse order. That's roughly the idea?
Yes.
Okay, thank you.
Are there any thoughts on like making, if there's some like last minute logging that you need to flush out? Are there any thoughts like how you could?
Sidecars today already have this mechanism. They just ignore SIG term for some extra duration of time and try to wrap, like clean up all the buffers. So this will apply still.
Okay.
Excellent. This is very exciting. So with that, Michelle.
Hello. For folks that don't know me, I am one of the SIG leads for SIG storage. I came in here because I wanted to let folks know about this user end table community called Data on Kubernetes. They're a user, it's a community full of people who are trying to run stateful workloads in Kubernetes. So there's a lot of database vendors here that are writing operators, and there's also just users of those operators as well. And I'm trying to organize sort of a regular roundtable session with this group between Kubernetes maintainers and people from the DOK community. And hopefully, I think we can my goal is we can sort of get direct feedback from users about, any sorts of friction or problems or things they like to see us enhance in Kubernetes to make their lives easier. And but yeah, so we are going to schedule a first roundtable session in January. And so I'm just kind of going around to all the SIGs to gather interest. And so when that session is actually scheduled, I can reach out to everyone here with that. And I think eventually, if from that first session, if there's enough topics to talk about to be worth creating a working group or something like that, like a stateful working group, I think that is also a potential option on the table. And so yeah, that's all I wanted to talk about here.
How will that be different from SIG storage, the working group? Why?
I think the idea is that running a stateful workload is a lot more than just storage. Storage is just a small piece of it. But they might have specific scheduling problems or maybe specific node problems or networking problems that they need to deal with. So that would be the purpose of the working group, to kind of put together this like cross SIG sort of because the problems might be cross SIG.
Yeah. I'd be interested to see how you're going to formulate the exit strategy. We have faced some back and forth on working group batch as well, which I feel it's like similar to what you're trying to do, right? But for batch now, this is for stateful, so trying to have a forum for.
Yeah, that is a good question. I don't know, maybe, I guess a working group is technically supposed to be temporary.
Mhm.
I don't know, maybe this could end up turning into a more long-term thing. It's a little hard to say right now.
Sorry, does it have any relationship to a user group from CNCF, or is this separate effort or ad hoc group?
I think this is not related. There's like a SIG users or something in the CNCF, I think. Is that right? I don't think it's related to that. This is a whole completely different group, and I don't think it's sponsored by the CNCF.
Okay. Yeah, the figure in CNCF is called user groups. And one of them, for example, is the research user group.
Mm-hmm. Yeah, I don't think this is related.
So what's the best way to participate here?
I think just add your name here, and then when the first meeting is scheduled, then I will be reaching out to everybody. I guess I should probably find a better way. Maybe like a mailing list or something. I'll think about maybe we'll create a mailing list. That might be better.
I guess you could still consider reaching back to CNCF and figure if starting a user group is a good idea as well.
Yeah.
The CNCF side.
Yep, I can definitely look into that.
Okay, with that, I think we have 5 minutes left. 3 minutes left. Any last minute questions? Okay. Well, okay. We'll see you in the next meeting. After the
Meeting
new year.
maybe.
Yes, in 2 weeks we don't have a meeting. When is 2 weeks? Yes, in 2 weeks we won't have a meeting. Let's cancel that one. It's December 29th. So, but we'll see you after New Year's. So happy holidays, happy New Year.
Happy holiday, enjoying the break.
Bye.
Bye.